Lesson 866, the Pythagorean Theorem, exploring squares in right triangles. In this lesson, you'll explain what the Pythagorean Theorem says. In your notebooks, you are on page 185. And our learning goal today is short and sweet. Explain what the Pythagorean Theorem says. So let's take a look at some squares that are made out of the sides of some triangles here, and we're asked to find the missing values. Now, I'm going to fudge this a little bit for my purposes here, so bear with me. And we're going to record what we notice about what we see. Well, let's start with triangle D here. Now, this is where I'm going to do a little bit of fudging. I need to say some things about right triangles. So I'm not going to wonder anything today. I'm just going to change this to some information about right triangles. And we're going to start by drawing a right triangle and labeling a few things so that we have some vocabulary that we can work with moving forward. So what makes it a right triangle is that it has a right angle. And as we're using the Pythagorean theorem today, I'm going to be referring to something called the hypotenuse, and I'm going to be using green for the hypotenuse as we go here today. And the hypotenuse is the longest side of a right triangle. The hypotenuse is the longest side of the triangle. And the two shorter sides, we're going to call the legs. That's a little less important. I mostly need to know which side is the hypotenuse. So we have a leg here and a leg here. Sorry, I'm doing all this on the inside of the triangle, but I wanted to save the outside for some letters that we're going to be using. The two legs, we're going to call A and B to refer to these. And the longest side, the most important one, is C. We always have to call that one C if we're going to be using the Pythagorean theorem. So that's some information about right triangles that I'm going to apply as we talk about triangle D. Triangle D is a right triangle. So I'm going to highlight the two short sides. Those are called the legs. And I'm going to highlight the long side. That's our hypotenuse. And we're asked to find the missing values. Now, one way that we already know to find the missing values of these squares is just to find their area. Well, side A is no trouble at all. I can find the area of side A because it's just sitting nice and flat. 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. For B, it's nice and pretty as well. I can see that that square has 1, 2, 3, 4 square units. C is a little bit trickier. You know what? I'm going to have to go back and do what we've done to find area before. I'm going to break up these triangles. I'm going to, let's see, it's going to be a little tricky because I don't want to overlap too much in here. Okay, so if I do that, I can see there's one square in the middle. I can see that this triangle, let me find the area, 1/2 base times the height. The base is 3, the height is 2, 1/2 times 2 times 3. Okay, so the area of that triangle is going to be 3. So that triangle's 3, that triangle's 3, that triangle's 3, that triangle's 3, and there's that one square in the middle. So I have a total of 13 square units. Oh, what a pain. I can do it. I have the tools to do it by finding the areas of squares. But I know that A squared is 9, B squared is 4, and C squared is 13. So I'm going to come back to all of those three numbers in just a moment when we talk about the Pythagorean theorem, or when I talk about what we notice. But I'm going to go ahead and just fill you in on what these areas are. One thing I notice is that this isn't a right triangle. So there's no side that I can call the hypotenuse. Let me just find these areas. I can count this one up. That's the same as the other one. C squared, this time it's 8. We could do this the long way, but I'm just going to let you know. And B squared is 5. And here's what I noticed. I noticed that in the right triangle, A squared plus B squared equals C squared. So A squared was 9 plus B squared was 4, equals C squared. C squared is 13. 9 plus 4 is 13. But in the non-right triangle, it's not true. In the other triangle, A squared plus B squared does not equal C squared. 9 plus 5, I'm sorry, 8 plus 5 doesn't equal 9. If it did have a hypotenuse, it would be the longest side, but that's not the case. Okay, so we've kind of introduced the Pythagorean theorem. It's this formula right here that says this leg squared plus this leg squared equals the hypotenuse squared. And that's true for every right triangle. Let's go ahead and move on. In triangle D, the square of the hypotenuse, 13, so let me do this, is equal to the sum of the squares of the legs. 13 was equal to the sum of the squares of the legs. 13 there. And that relationship is true for all right triangles. It's known as the Pythagorean theorem, and it's like having a screwdriver in your toolkit. Everybody's got a screwdriver in their toolkit, and they use it all the time. The Pythagorean theorem is one of those tools in math that you will use all the time. Another way to describe this relationship is, well, here it is. A squared plus B squared equals C squared, where A and B are the lengths of the legs, and C is the length of the hypotenuse of a right triangle. Let's take a look at a couple of triangles down below here and decide if the Pythagorean theorem is true for each of these. And we'll show our thinking. Okay, well, we have a triangle here. They've labeled A, B, and C. I see that C is the longest one, or C squared is the longest one, so that must mean that C is the longest one. So let's try this out. Does A squared plus B squared, and put a question mark above the equal sign, does it equal C squared? Well, they told me that A squared was 50. They told me that B squared was 37. And they told me that C squared was 85. Now, is that true? Well, 50 plus 37 is 87. Well, close but no cigar. They're not exactly equal, which must mean that that one's not a right triangle. I'm going to say this must not be a right triangle. Because if it was, then A squared plus B squared equals C squared would work. Well, let's look at this one. This one looks a little trickier. First of all, they didn't tell me which side was A, B, and C. I told you earlier that the longest side was the hypotenuse. That was the most important one to identify. So the square root of 50 is the biggest square root. That must be the longest side. It doesn't matter which side you call A and which side you call B. What's important is that those are the two shorter sides. All right, well, let's try this out. Got to be careful with this. Here's the Pythagorean theorem. A squared plus B squared equals C squared. And if this is a right triangle, that should work. Well, I'm going to call this A. I'm going to call this B. And call this C. So A is the square root of 10. And I have to square that value. And we talked in class about how if I want to take the square root of something and square it, the squaring and the square rooting really just cancel each other out. So the square root of 10 squared is just 10. Let's do b. Well, the value of b is the square root of 40. And I have to square that value. I'm squaring b. Well, same thing. The square root of 40 squared. The squaring and the square rooting just cancel each other out. The square root of 40 squared is just 40. Let's see if that equals c squared. Well, the value of c is the square root of 50 according to this diagram. I have to remember to square it. The square root of 50 squared should be 50. And it turns out that 10 plus 40 equals 50. And the right side of the equation was 50. So the Pythagorean theorem worked out, which must mean that this is a right triangle. That's why it worked. In summary, what does the Pythagorean theorem tell us about the side lengths of a right triangle? Well, in a right triangle, the sum of the squares of the two shorter sides, I'll say that one more time, the sum, that's the plus sign, of the squares of the two shorter sides is equal to the longest side squared. That's what the Pythagorean tells us about any right triangle. And we can use that to find the lengths of sides of triangles moving forward.